Okay, so today we're going to look at estimating sums using different approximations, left, right, and midpoint. This is the way that we can estimate the area under the curve. Later in the unit you'll learn that this is actually integrating a function, but we're approximating it based on the fact that sometimes you can't integrate everything. So we want to sometimes approximate or guess the area under a curve. And we're going to use some of these methods to do it. Okay, so we're going to start with the function y equals negative x squared plus 5. And in this example, we want to use a left-hand Riemann sum. We're going to use 4 rectangles. So in order to determine the size of my rectangles, if I want to go from 0 to 2, I have to start by finding my size, the width of my rectangles. So in this case, it's going to be 2 minus 0 divided by 4. Because I want equal size rectangles, and I'm going from 0 to 2, so each side of my rectangle will be a half. So if I'm doing a left-hand Riemann sum, what I want to do is I want to go to the leftmost part of this curve. This is the curve of negative x squared plus 5. I want to go to the leftmost part of the curve, and starting at the leftmost part of this curve, I am going to draw a rectangle to a half. And yes, I cannot draw a straight line, sorry. Just imagine that that's a straight line. So if I were to find the area of this rectangle, well, the first thing I notice is that its width is a half, and then its area is length times the width. So what is the height of this rectangle? To find the height of this rectangle, I am evaluating the function negative x squared plus 5. So the height of that rectangle at 0, since this point started at 0, would be negative 0 squared plus 5, which is simply 5. So I put my first set of order pairs here. So when x is 0, the function is 5. Then I'm going to go to the next most left part of that curve. Let me get a different color. So now the next leftmost part of that curve, I'm going to draw another rectangle. Let's see if I can draw this line straighter. Oh, I'm a little bit better this time. Oh, got off there. Okay. So this time my rectangle, each interval is a half. So I start at 0, and so this is a half. So I'm going to evaluate the function once again for a half, and I get negative 1/2 squared plus 5, which gives me 0.475. So that's that is the height of my rectangle. What I'm going to do is, since all of my rectangles have the same height, I'm going to wait to the end to multiply them all by a half. Okay, so my next rectangle, again, I'm going to start at the left and draw my little rectangle. I cannot draw a straight line. And so when I draw my next rectangle, this was a half, so this would be 1, because each of these is half. So this would be 1. So I started at 1, so I'm going to evaluate f of 1. It's negative 1 squared plus 5, which is 4. My next rectangle is going to start at the next left point on the curve. So that's here. And again, since this is 0, a half, 1, this has to be 1.5. So now I would evaluate 1, f of 1.5, and I get negative 1.5 squared plus 5, and I find that to be 2.75. Notice, because I'm doing the leftmost triangle and I'm going from 0 to 2, I'm done. Okay? If I were to take this last triangle, that's outside of my area because I can only go from 0 to 2 according to the estimate that I'm doing. Okay? So that's my leftmost right triangle. So I add up all of my heights, and then I take my height and I multiply it times a half. And I'm multiplying it times a half because each width of this rectangle was 0.5. So that's why I'm multiplying it by a half, and the answer is 8.25. I don't worry about units unless they give me units. So there were no units given, so I don't worry about it. Alrighty, let's do a right Riemann sum. Now, when I'm starting with the right Riemann sum, and I'm going from 0 to 2, so I'm doing, again, 4 rectangles from 0 to 2. So once again, that's 2 minus 0 over 4, which gives me a half. Because I'm starting at the rightmost triangle, I'm going to start at 2. So at 2, I have to find where my function is, what's my y value at 2, and then I draw a right triangle. So the height of my right triangle, I have to evaluate my function at 2. That's negative 2 squared plus 5, which is 1. That's my rightmost triangle. So now I go to the next most right point of this curve, and this would be at 1.5. The next one would be at, and I've evaluated that to get 2.75. The next one would be at 1.0, and I evaluate the function at 1.0 to get 4. Notice these are the same values that I got in the last estimation. The only one that changed was the beginning, and so this one would be 0.5. So everything remained the same except for the 2. I had to add the 2, but notice I also dropped the 0, 0. I'm sorry, the 0, 5. I dropped that one as well. So once again, I add up all my y values, and so just to make sure that you understand, I'm evaluating f of 1.5, f of 1, and f of 0.5. Exactly how I did in the previous problem. The only difference is that I added this one and took away the leftmost point. So once again, since all of my rectangles are half an inch or half a unit, I have to multiply by a half, and I get that my area is 6.25. That's the estimate. Notice that this is an underestimate because I have lots of white space. Whereas in the one that we did previously, if we go back and look at that one, we see that this would be an overestimate because I'm over the curve. And so we say that if the function is decreasing, so we have a decreasing function, then the right RAM is an under approximation. And a left RAM is an over approximation. And it's just the opposite if the function is increasing. So if the function is increasing, then left RAM is an under, and R RAM is over. Okay? And you can often see questions like that on the AP exam, so that's one of the things that you kind of need to know. I always just sketch it and see. Okay? So once again, this is an increasing function, so when we do LRAM, it's going to be an over approximation. I'm using 8 rectangles from 0 to 2, so I start by doing 2 minus 0 divided by 8, and that gives me 1/4. So those are the size of my width, and when I draw my left rectangle, I start from here. Notice that first one is just 0. It's an under approximation. The next one, let me get a different color. The next one, shouldn't have gotten red, will look like this. You see all the white space above it, which is why it's an under approximation. The next left rectangle would look like that. Okay. The next one would look like this. And so on and so forth. And each time I evaluated the function, what was the function? It's up here. Each time I evaluated the function with these values. So the function was x squared. So this is what a left Riemann sum would look like. Of course, your rectangles would be a lot nicer. Follow one, because I'm going to 2, would look like that. So notice all the white space, so that's why it's an under approximation, and we said that before, because it's increasing, left ram is going to be an under approximation. And so what I've done here is I've evaluated f of 0, f of 1/4, and so on and so forth. I add them all together, and then this time I multiply by 0.25 because that was the width of each rectangle. Okay? I think we're going to do the same thing with RRAM. So I just want to give you an idea of what those graphs look like, what the picture would look like. Let me start with green. So the first one, I start at RRAM, so I start at 0.25. And notice it's slightly above the function. We draw it over. It's slightly above. And then as we proceed, you'll see that it gets more and more pronounced. And this is the right one. And we come and hit it. And then we proceed to draw a line right. Okay? So on and so forth. Again, notice I didn't use 0, 0 in my right Riemann sum, but I did use 2. So I'm going to start, I should have started here at 2. I promise, kids, I haven't been drinking. I just can't draw a straight line. Okay, so that's what my right, that's the first one, would look like that. So it has a height of 2, and then to evaluate it, I just simply put it into the function. So this is f of 2, which is 2 squared and 4. I add them together, and once again, I multiply by 0.25 because that is the width of the rectangle. Now I want to show you an MRAM. Okay? For an MRAM, once again, we're going from 0 to 2, and we want 4 rectangles. So 2 minus 0 divided by 4, we get 1/2. Okay? So 1/2 is the length of my rectangle. But the way I get that is by going to the very center of a half, which is 0.25, and that's how I get my y value. And then I go from the left to the right to make my rectangle. So this is my rectangle. Notice that some of it is under the curve, some of it is over the curve, so it's a little bit more accurate. Okay? And so since I hit the function at 0.25, I evaluate 0.25. Okay, and I get 1.5. I'll probably just use the calculator. And then again, my second, I need the distance between 0.5 and 1, which is 0.75. Excuse me, I really can't draw a straight line. This is sad. Okay, so that rectangle looks a little bit like that. And again, I'm going to use 0.75. I'm going to evaluate the function at 0.75. And then the next one would be between 1 and 1.5. I know you're laughing at my straight lines, but that's okay. My husband loves me anyway, even though I can't draw a straight line. Okay? So and then the next one would be 1.75. Oh, that one was decent. Okay? And so I would evaluate 1.75. Now, again, I evaluate this. I add all of these up. But this time, I'm going to multiply by 0.5 because 0.5 was still the width of my rectangle. So my rectangle went from 0 to 0.5, so my width is still 0.5. So I multiply everything by 0.5 to get an answer. Okay, let us do, and so we did tan x. I changed this from your notes, so we're going from 0 to pi over 4 and only doing 2 rectangles. Then we're doing midpoint. So if I go from 0 to pi over 4 doing 2 rectangles, it's pi over 4 minus 0 over 2, which is pi over 8. So the width of my rectangle is pi over 8. But since I'm doing a midpoint, I have to go halfway between 0 and pi over 8, and that is pi over 16. So that's my first rectangle. So I used pi over 16, evaluated that to get 1989. Then the next one, okay, so I'm moving, I added pi over 8 to pi over 6, and I got 3 pi over 16. So again, I draw my rectangle. I'm starting at that midpoint, so I'm going to have a little bit above. That one wasn't too bad. And a little bit below. Okay? And that's how I got my second value. Then once again, I add them up. And because my width was pi over 8, I multiply everything by pi over 8. I always multiply by whatever that width is. Okay? So I'm going to end this video here and then come back for how to do it with tables, which is very important because that's what you see most often on the AP exam. So come back just a minute.